So welcome. We've been working together for quite a few months, Pavel and I, to put together this talk. And Pavel has built a demo. So as Alex has already introduced us, we'll just move right in. We'll start out to talk about decentralized identity management and just to set some expectations right off the bat. We've tried to avoid hype by any stretch of imagination. We've tried to stay away from cryptocurrency. So if that's what you're here for, I'm sorry. We're probably not going to talk about it at all, maybe just a teeny tiny little bit. Really, we took an approach because we know a lot of our customers are talking about blockchain, researching it, and are starting to actually put it in production. So we looked at our customer use cases, and we built a demo based on kind of that practical approach. And we used Stitch for the majority of it. And the idea is to give you a sense of what other applications besides cryptocurrency can you use blockchain for, what is it good for, and encourage you to go build your own. So that's sort of our premise. Just to really set the stage, there's a lot of statistics that you can come up with about who's using blockchain, how and where. The reality is a lot of people are talking about it. Very few of these projects are in production. This is just a stat from Stanford University about the study of blockchain. And the reality is, for identity management, it actually makes a lot of sense. So that is for verifications of anything from assets to personal information. The sort of decentralization and the cryptography pieces really fit well. So that's what was one of the reasons why we were inspired to use this use case. So just a quick primer on how blockchain works for anybody who's not familiar. We start out with a block. In this case, that block can contain arbitrary data, and that's where I should start and really introduce the fact that you really do need a database with a blockchain. And if you think about any commercial solution that's out there that's available, it actually has a database. Anything from even Ethereum actually has a database inside. It's a very primitive key value store, but if you're building a blockchain for an enterprise application, you actually will need to deal with data, and you will need a database. So in this case, the data can be arbitrary data, and in our case, it's going to be a financial services example, so that's what we have. And then to make it a blockchain, some things are required. A hash, everybody here knows what a hash is, and a previous hash, which is how blocks are linked together, and an nonce, which is basically a number that constitutes the proof of work and how hard you want the proof of work to be. So really, computing the nonce is what typically happens when folks talk about the proof of work. So that's sort of another piece that kind of makes it, it's a piece of cryptography that basically makes the blocks cryptographic. And it is, so blocks are connected together by basically pointing one hash to the next, right? So that our previous hash points to the block before us, and off we go. And we build these blocks and we link them together by virtue of these hashes. So fairly straightforward. So how our customers are using blockchain today? A number of use cases. Obviously, you saw Coinbase on stage today. There are a few customers in the digital currency space, if you will. And there are actually customers in the government space as well who are using things like contract negotiations and giving some transparency into who the vendors are, what contracts are being negotiated and in what terms, to give everybody a fair chance, but also to hide some details. Digital trust is sort of a big emerging trend, and obviously supply chain. We have some customers in the IoT space who are talking about vehicles and vehicle-to-vehicle communication, which needs to be, again, transparent and open, but at the same time secured. Financial services would probably constitute our largest vertical, and for that, there's a number of customers who effectively do everything from anti-money laundering to trying to figure out, again, identity verification. And this demo was taken by, basically it was a customer example of how somebody's actually using MongoDB. So there's plenty of examples of how blockchain is out there in financial services. So that's what we went with. We built this demo based on a customer from a standpoint of a financial services institution that basically has a network of banks that wants to be transparent and get new customers, but at the same time, so there's some limited trust, but at the same time, nobody's going to just share their customer master with their banks, even if they're in the same network. Right, at the same time, customers just want the experience of going and logging in and interacting with their bank and checking their bank account and possibly applying for new offers. So you basically have your digital assets, such as your information that you're sharing already. But wouldn't it be nice if you actually could get offers based on your specific digital identity without really revealing every possible detail about you? And just by logging into your bank, you could actually have personalized offers that were specific to you. And that could all live on blockchain. So that's kind of what we imagined. So for the customer standpoint, obviously everybody wants to be in control of their digital identity. It's actually something that's required because physical data, we want to understand how it's shared, who uses it, how it's leveraged, and so it's becoming more and more relevant as we sort of interact with entities in this digital world. So this is really becoming a key area. And so from the customer standpoint, we built this app, and by we, I would say mainly it's Pavel who put a lot of blood, sweat, and tears into this. And we're going to show you a demo of exactly what this looks like. But basically, it's just like a banking app, except it's special in the sense that some of this information is stored in the blockchain, and we're able to get new offers and share information, but in a limited fashion with other banks by signing it and kind of sealing it into the blockchain. And from the financial services provider, what they get out of this is they're able to interact with one another and with customers, attract new customers, respond quickly to changes, manage risk because they can actually take data that's already in the blockchain, calculate customers' risk profiles, understand who they're competing with. At the same time, there's sort of a semi-private chain that allows you to leverage partnerships with one another. So you're sort of in a situation of limited trust, some trust, but not absolute trust. And also get the latest data from customers. Oftentimes, getting the most up-to-date data and understanding your customer is actually the biggest bottleneck. So that's something that can be solved with an application like this. And so how does this work? Well, a customer signs in to their account, and alongside, of course, the blockchain information in MongoDB, you also have your customer 360, your account information, other pieces of information that's maybe more complete. And probably a copy of blockchain, or at least a partial copy that you could also analyze and use for things like risk profile that I've already mentioned. And so as you sign on, let's just say you're interested in a specific offer, you actually, by virtue of subscribing and wanting to participate or get latest offers, a transaction is created on the blockchain. And then these transactions get grouped into nodes, and all of these nodes get propagated into the blockchain. Other nodes are listening for the blocks to get approved, and once the blocks are approved, they get sealed into the blockchain. And each financial services institution can have one or more nodes. So sort of the creation of blocks and how they get approved is by consensus with other partners in that chain. And to give you more of an architectural example in a demo, I'm going to hand it over to Pavel.
Yeah, thank you. Hi, everyone. Thank you, Jane. So I'm Pavel Dukovny. I'm a senior technical services engineer. And I wanted to show the main architecture we thought about. So we have 4 key components here. We have our MongoDB Atlas, which is the heart of our deployment. Around it, we have our Stitch app, which basically serves as a web server and access to our MongoDB Atlas, and lets us use various models that I'll talk more about them later. Around this, we have our blockchain network, which consists of those nodes that produce the chain. Those nodes have access to our blockchain through authentication as well. And finally, we have our bank applications, and we have our users. So when a user logs in, it passes its credential, keys, or data to the bank's app. The bank application goes and passes it through Stitch to our MongoDB Atlas, and a transaction is recorded. Once a transaction is recorded, a notification is pushed into the nodes. And the first node that gets it basically approves it, runs like whatever risk analysis or whatever analysis we want to run on this transaction. Once it's approved, other nodes are receiving a notification that they need to approve this transaction. The same happened with the blocks. Once a block is created by one of the nodes, the other nodes needs to approve them. Once a majority is reached, this block considered to be one of the blocks in our blockchain, and everybody repopulates their blockchain copy. Once this happens, those credentials considered valid, and this data is considered valid by our bank. But since other banks are connected to the same network, they can get access to this data. And if we want to limit our access to the data, we can use cryptography to actually encrypt our values and share them only with banks or financial institutions that have those private keys. So, it always looks good on the board, but we wanted to show you a demo. And we wanted to actually go and build it with some of our coolest features. So let me explain what you're seeing here. So on the left side, we are actually seeing our app on our mobile phone. And on the right side, we see our nodes, which is the nodes that were shown as the blockchain network. And once I'm going to perform actions on my application, you're going to see how my nodes are starting to respond to those changes and starting to build the information sharing.
Quick question.
Can we do it in the end? Can you? Or
I just want to understand, with these nodes, are these nodes part of your, within the MongoDB cluster, or are they separate things?
there are code that is written in Node, and I'm going to walk through that. But they are currently running on this laptop. But they can run anywhere, and they can scale, and they can run whenever you want them to. So many parties can run them. They are the working node that produce the blockchain. Yeah. If you want to. Yeah. Yeah, they're part of the blockchain network. They are, if we're going to go to cryptocurrency, they are the miners. But we don't.
Yeah, we don't mean replica sets. They're not MongoDB nodes.
They're not MongoDB nodes.
They're
working
code
nodes
that
for the blockchain network.
Yeah, that basically will produce the nouns. Will do the bit of cryptography to actually make this a block.
Yeah. So as I'm logging in, so a little delay in the network, but you can see that. You can see that we're logged in, and you can see that one of them produces a block, and the other ones actually verify the block and verify the transaction and pushed it into the block. So it reacted to my action. Now, let's say that I want to share some of my information. So let's say I want to share my credit score and my asset range, and I want to share it with those partners. Once I do that, the blockchain reacts. And another block is produced. And once this block is submitted, other parties can now see some of my information and consider to give me other offers. So since they got my permission to be exposed to this information, they can offer me a credit card, for example. All right. Yeah. Going back to Jane.
Yeah, so just to talk a little bit about, why would you use MongoDB for blockchain? Again, the database component is sort of very crucial to this, because as you remember to my very first slide about blocks and what makes it a blockchain, of course there are pieces that you're needing, like the cryptography pieces and the hashes, but the data that lives in a block is very rarely, in a very primitive cryptocurrency situation. Of course, it's in a wallet situation. It's, I gave Pavel, $10, right? But in the real world, like in an identity situation, as we're discussing, it's much more complex, right? So you want to share an asset range, for example. How do you do that without actually revealing what the assets are? How do you reveal something about the customer? And then, moreover, for a real entity, for a bank, how do they know and can go back in history and actually take snapshots and analyze what they've actually shared? So the power of the database is really crucial here. So as the use cases get more and more complex, the need for a full-featured database become more and more relevant. So in this case, why it was important for us to have a database was because obviously we could use any programming language. In this case, it was JavaScript. We used Node.js and Stitch. It was flexible, right? And so as you're thinking about your application, having a database that's very flexible that can deal with different kinds of data, not just cryptography data, and simple key-value pairs was very important. And you will likely have to integrate the blockchain with your existing applications. So that's another thing to consider. The fact that you could actually build this very quickly, especially on Stitch, we spent some time, but it wasn't like a full-time job for us, building this demo, right? So it was weeks, not months, not years. And that's what's required to iterate in this environment. And the fact that really we could use a variety of access patterns. What Pavel will show you in a little bit is we used kind of the full-featured MongoDB capabilities to really kind of unravel the blockchain. So that was super useful. We also built it on Atlas, and again, I don't have to explain how important it is in today's environment to sort of develop quickly, not focus on an emerging area like this, not focus on running a database, right? So the fact that it is a global deployment, so you can actually imagine this scenario for a network of banks that is worldwide. So that was so we did build this on Atlas, and that's why. And we built it on Stitch because obviously the serverless nature allowed us to build less code. It allowed us to use pieces of sort of authentication, use serverless functions to do some of the heavy lifting, like approving of the blocks, like looking and analyzing the blockchain. So that was really the building block for us, or a very key component. Now, this is a security track talk. And so what I really want to point out here is all of the established security practices sort of still apply. We did use anonymous authentication in Stitch, which is something we could do for a demo. But the reality is, for any financial institution out there, we know they're using 2FA and LDAP and other components that are so crucial for security, right? So just because there's cryptography doesn't mean that you have to throw everything else out that we've known about security for years and years. The fact that there's full database auditing and Stitch logging allowed us to actually have the auditability piece of kind of the 4 areas of security. You could have encryption, and in reality you probably would. And if you are building other applications or interacting with the blockchain, you probably want things like VPC peering, network isolation. You most certainly will want Stitch rules, right? So just because as an administrator or analyst I can do analysis and see data doesn't mean that I will want to see every piece of the blockchain. So you can still use Stitch rules on top of existing blocks to filter out some of the information that's maybe personally identifiable. So that all of those, the point of the slide is to kind of remind you that just because there's blockchain and blockchains are secure, you still have to think about all of the enterprise security pieces in totality and how they fit together. And I'm going to pass it back to Pavel to walk through the code.
Yeah, okay. So now the interesting part. So just one sentence. I think we as developers not always talk about our feelings. And and the thing is, you probably imagine that as a technical service engineer, I saw a lot of MongoDB products. I've interacted with a lot of MongoDB products. But it's only those times where I can actually realize a use case from start to end that I understand the power of the products of MongoDB. And it was a pleasure. And I learned a lot. And I want to share it with you. So let's start about talking what building blocks or what APIs do we need to implement this solution. So we can basically scope them to two sections. We have the backend section and we have the frontend section. So the backend consists of our nodes, which are the blockchain network, which produce those pieces of information shared on the blockchain. There are two main classes here. So one class represents a block, and it has two main methods. It has a little bit more, but those are the two main ones. So verify a block means that I can verify that my hash is what I expect it to be, and produce a block, which is basically calculate the needed hash, the signed hash with the nonce. In this example, it's just a brute force calculation, right? I'm calculating hashes until I reach the correct signing format. The blockchain have a main class that's called add block. So whenever I produce a block, I want to add it to the blockchain. We use Stitch. So we separated some of our logic to our Stitch functions. So they can run things like approved by majority or populate user info. So we can integrate third-party services with Stitch. So we can leverage it to gather IP information, gather location information, gather maybe some risk analysis services that we can integrate into this. So populate user info is a function that can call other services and just get the user data and then consider what it propagates to the chain. We use rules, as Jane mentioned. And with rules, we actually can define what information a certain login or a certain node can see based on MongoDB documents or based on functions. And I will show it in a minute. In MongoDB, we have a blockchain view. And this is an interesting point. So our blockchain is basically a view based on another collection. And I'm going to make it more clear in a second. On the front end, we have our application. So we used Stitch.js SDK to build our web, or in this case, certain mobile web application. So in Stitch, we used 4 models. We used the authentication model. And Stitch allows us to use various types of authentication. Some of them are pretty sophisticated. For the simplicity of the demo and the code here, we used email and password for our application. And we use anonymous authentication for our nodes. Because the information on the blockchain needs to be shared on the network, in order to scale, I don't want to negotiate credentials with other partners. So I'm just saying, I just want to identify each node by a UUID. And anonymous auth gives me this opportunity. We use rules. So let's look at the pending blocks collection. So we have a collection that's called pending blocks, and it has blocks that have not yet been approved by a majority of nodes. So it lets write to it either if approved by majority is still false, which makes sense. Either the previous hash is the initial hash, because this is the Genesis block and it has no real sophisticated value. or if a function called approved by majority returns true. So we actually can verify that nobody gonna tamper with our data unless it is approved by majority. We also can decide what fields we're gonna project. So for example, if somebody queries the profiles data, we can actually go to the root document that we're selecting and see if in the array, in this path, the array assets shared have a date of birth or an assets range value, then this value will be available for queries. But if it's not there, then a user who does not own the object cannot see this data. So we can actually make a projection rule based on our document's data. So it can be a projection per document here. So every time we update one of the documents with another value, this value will be projected or not. It's a powerful thing. Yeah, just to emphasize it. We used functions. So in our functions, we can actually see approved by majority. And notice that this function is marked private. That means that the client SDK cannot run it. So our nodes cannot run it, and our app cannot run it, and nobody outside of Stitch can run it. Only Stitch can run it as part of its rules or triggers. In this case, it's a rule. So we're querying the nodes, we're querying the block, and we're looking if the approvals array in the block is indeed the majority of the currently connected nodes. This way, we can guarantee that only if this function returns true, this block is really approved by majority. And another cool thing is that Stitch has a utils.crypto. So we used HMAC hashing to actually verify if a block is indeed have the correct hash compared to what it says it has. So we can double check it on the nodes layer, and also once it actually inserted into our database, which is powerful. We use HTTPS services. In this case, we used IP Stack, which basically is a service that allows us to gather information about our IP and the location of IP. And it's just an example of how we could integrate it into our system. So it's really easy to call services. You just do a get with the service name, and then you can get the access key from our encrypted values inside Stitch from the context and call it and receive the information within the Stitch functions and populate it through Stitch. So there's no code needs to be done on the client side. We use change streams. So change streams was introduced in 3.6, and it's really powerful with the distributed blockchains because every pending block or every pending transaction can be populated to the nodes through change streams. And using match expressions, we can actually define that we want to get blocks or transactions that we have not produced by ourselves. Since Stitch triggers are working on the server side, I actually used a hybrid solution here. So I'm using Stitch on one hand, but I also have a connection to MongoDB, and I can do whatever the MongoDB driver of Node can do. This way, I'm not locked into Stitch, and I can do various models in Stitch and various models in MongoDB. And as I mentioned, our blockchain is actually a view based on the graph lookup stage, where we can traverse our chain by connecting the previous hash to the current hash. And then this way, we can actually construct our blockchain only for blocks that are approved by majority and get a organized list. We wanted to mention that although this use case, we talked about a financial institution sharing information use case. But actually, if you think about it, this kind of concept can be helpful for other industries. You still have entity one and entity two who wants to share information or share something on the blockchain, whether it's log lines or whether it's any other information, any contracts that they want to share. So we have two entities who want to share information. We'll need to have nodes that produce the chain and construct this blockchain network. We'll still need components like whether it's a valid node, whether the blocks or the transactions are approved by majority, and whether this block is verified or not. And in our database, we'll still need to have a nodes collection. We'll still have the blockchain view. We'll still have pending blocks. And we'll have pending or approved transactions or pending data and approved data. And we'll have our user data as well.
Yeah, and I think just another thing to emphasize, things like the change streams and ability to listen for new block creation without really having to build that logic from scratch. With change streams, we can do that, right? So that's already given to us for free, if you will. Things like graph lookup allows you to actually traverse the relationships. So you can have, the whole point about blockchain is that everybody has a copy, right? So how do you traverse and make sure that you understand exactly how the blocks are connected so that nobody can sort of fake a block and insert it into the blockchain? That would invalidate it, right? And the graph lookup is actually allowing us to traverse the entire blockchain, and we don't have to build a graph search functionality. So those are the important building blocks that we're able to use. So where could you use this? Again, the idea was to sort of model this after financial services, but open up the paradigm to other industries. So fraud in the supply chain around goods that could be moving through various distributors, right? So anything around goods moving between parties and kind of creating digital signatures, and that could really go into enforcing if something is produced in a certain facility, right? So we showed you using an IP address clearly works for folks signing on and sharing their digital assets, their information, because if you're meant to be living in in Canada and you're signing on from Taiwan, you can certainly verify that that information is suspect, right? Same would work in a supply chain situation. In the government space, there's a lot of kind of public or blockchain for good use cases around this, where you can create voting systems, and that has been created. Land rights or census data in a similar paradigm. Definitely something that would work for drug safety or food safety, right? So if you basically had to trace raw materials and understand how they ended up in a substance or a drug or a food product and had to then potentially contain an outbreak, you could certainly traverse the entire blockchain. But again, because you have data that is sort of rich, you can actually query, create complex queries and understand how that all fits together. So why build blockchain apps with Mongo? Again, we encourage you to sort of use the paradigm, use the building blocks, pun intended, to build the blockchain. These are the things that we think particularly stand out about Mongo. And in the blockchain use case, so using Stitch, using authentication, including anonymous auth, so that you can have some anonymity between the blocks, using change streams, and potentially triggers to listen and verify to blocks, having a flexible schema where you can combine the cryptographic signatures with actually rich user data, or rich industry data is super important. Having schema validation, right? So if you wanted to enforce certain blocks to be a certain shape and have certain fields, you could actually do that. We didn't talk about it, but you could certainly do that. And then having graph lookup, able to analyze and traverse the blockchain so that everybody can have a copy and understand that blocks belong where they belong. So those are some of the things we want to leave with you. And I think with that, we'll thank you. This is available to download and use.
There's a GitHub repo with README file that allows you to set it up. Of course, you'll need an Atlas cluster and a Stitch application in place. We hope you enjoyed the talk.
Yeah, and if you have any questions.
Yeah.
Definitely take some questions now. I think we have time.
Yeah, so thank you for the presentation.
Give you this since we only have one mic.
Yeah, thank you for that presentation. That was pretty awesome how you covered all the bases in terms of the architecture. In terms of the use case itself, I have some concerns that I hope you can address.
Yeah.
So 3 concerns mainly. First of all, I saw that you had 1 transaction per block.
Yeah.
That's, I mean, right now, you know, Bitcoin, Ethereum, the biggest blockchains out there are having huge problems with scaling. One of the main reasons is that the consensus protocols, when you have a decentralized network, you can't, you have to get consensus, and that takes a long time. The more nodes in the network, the more that takes time. So how are you accounting for that? Second of all, the incentive. So for the validator nodes in the network, how are you incentivizing them to, you know, continue validating? Because in cryptocurrency, they're validated by getting awarded tokens, right?
Yeah.
And the third one is the actual reason for, I don't understand the reason for sharing identity information on the blockchain when all that information is cryptographically obfuscated. What are you verifying? I mean, in Bitcoin, in Ethereum, you're verifying that money isn't being double spent, or you're not spending money you don't have. So what are you verifying in this network?
Okay.
Yeah.
Okay, so let me address first the, yeah, I have a mic.
Oh, thank you.
That's fine. So first, yeah, I have 1 transaction per block, but this is for the demonstration. Because I have a low traffic network here, I've set up my limit of transactions per block to 1, just so that you can show that blocks are created. If I had like a multi-tenant system, then I would probably say I would go for a larger number. And again, since change streams are asynchronous, there are periods of time that there could be, if there's a high volume of transactions, there will be more than 1 transaction, like a few hundred. But we still want to limit that, right? We don't want to have like a 10,000 transaction in one, because if we want to go over each one, that will be expensive. So I think this is a matter of configuration. The answer to this question?
And I would just add to that, remember, this is not a cryptocurrency use case. So we're actually thinking about an enterprise customer where, you know, in this specific example, the network is limited to maybe tens of banks, right? Maybe hundreds, right? But the idea is you're not really, these are not individuals, right? These are institutions. And then the customers maybe in tens or hundreds of thousands, but like how often do you actually apply for a new credit card? Like not every day, right? So the idea is, so the scale and the concern with throughput is a little different when you put it into an enterprise example.
Yeah. I wanted to address what am I verifying. So I can verify risk analysis, right? So let's say Amazon thinks that a risk analysis should be done differently. So we can negotiate on a provider that we both agree on doing that. And in order for Amazon to verify that I'm not cheating, that I said, yeah, look, I will use this provider, but I actually don't, so they can also run a risk analysis, right? Because they have production nodes in this network. They're a partner, but they want to verify. They want to, verify that whatever I'm doing, I'm not cheating, in order to, to get or to push more customers to other customers to get commission or whatever terms are at stake.
And the reality is, you could probably get, a set of banks to agree to a set of APIs to just share that, but also the reality is it's incredibly hard, right? So is it easier to agree on the algorithm that you're going to do let's just say a verification for a new customer for a bank A would include, where they're from, their, one set of identity, or one set of pieces of information, and for a bank B it would be something else, right? So what you're verifying is that the customers who they say they are, how risky they are, should we lend them money, kind of any of the numbers that would make that customer a desirable customer. And I think the other question was
The third one?
Oh, yeah, the incentive. Yeah, so the incentive here, again, in a sort of a private, this is, again, a kind of a private blockchain use case. The incentive to cheat would be the entities are known to one another. Unlike in a, true sort of Ethereum blockchain, a kind of a peer-to-peer, very open blockchain, there is an incentive to cheat. For here, the entities are sort of known, and so there's kind of a handshake or an agreement that we all know who we are, and we don't necessarily want to.
Yeah.
We don't need an incentive. We know it's a partnership, right?
And another thing, a blockchain is immutable. So once I save something, if I'm gonna change it, then the blockchain will break, and then we can understand that something is wrong here. We can investigate. So. Okay.
As in, why would the validator node keep checking that everyone else is?
Well, because it's a service that you both invested in. Yeah, of course, the machines themselves doesn't have any incentive. The incentive of the partners is to give the customers as good experience as they can, although having this trust integration with the blockchain network, right? So it's in the partner's interest so that those members will work.
So in this example, would the banks be maintaining the verification nodes?
Yeah. Yeah.
For those that didn't hear, I said in this example, would the banks be the ones maintaining the verification nodes?
Yeah, they are.
Can you just clarify what's actually being stored on the chain as opposed to in MongoDB? It's unclear.
Okay. Yeah, sure. So this is what I brought the MongoDB Compass, and I wanted to show you exactly how the blockchain looks like in MongoDB. So we have our chain. It's a view, as I mentioned, and we have our blocks. And you can see that block 0 is the initial block with the previous hash of 000. And we see that the current hash connects to the previous hash. But yeah, the information here is a metadata on the block itself. And the data is actually a login that I've performed with this IP information and the assets that I shared. So this one actually has no assets shared because I didn't allow it yet to share. But if we're going to go to the last operation that I did, right? We go to data, go to shared info. You're going to see that there is other information that I'm allowed to share.
So you're duplicating every block, not only in the blockchain, but on MongoDB.
MongoDB is a storage behind
Yeah.
for each block.
Yeah. So if a node crashes, he has a.
You have to store data somewhere. That's the whole point. Blockchain is not. You either have to store data in a file system, or like in the case of Ethereum, you have level DB underneath.
That's the
right?
blockchain.
Like that's. Yes.
So it's like the dot data on the drive is now stored in MongoDB.
Right.
You're downloading it basically a copy.
No, each node holding a copy of it in its memory or whatever you store it, or even locally. But it also stored here. So this is the.
There's no local key that is stored.
No, there's no.
You're using MongoDB
Yeah.
to replace it.
So I have two questions. And one is that I am curious about the performance of the graph view with a large number of elements of the blockchain. Because it seems like unless it's very efficient and scalable, it's going to be linear. And the other one is I'm curious as to whether when you're envisioning the nodes verifying blocks, are they verifying the content of the blocks? Or are they doing sort of this standard thing you do in a blockchain where they're just verifying, I saw this block. This block seemed to be a real block to me.
Yeah. So as I mentioned, transactions can be verified against like risk analysis or whatever verification you want it to be. The blocks themselves, if they include crypto data, right? So what would I put on the blockchain? I will put the encrypted data. I will put my signature and my public key, right? with those three things, I can strongly say that this data was signed by a private key belonging to this public key because I have the signature, right? So the blocks are actually verifying whether, the nodes are actually verifying whether the blocks are aligned with the hashes, and if they have cryptographic data, is this cryptographic data legit? Make sense?
But you could design
Absolutely.
a different algorithm if you wanted something more robust.
Hi. My question is about the process of creating a block. It's not a competition based, right? It's a single node building a block and the rest of the nodes verifying it. It's in your design. I'm talking
Yeah.
about your design. Okay. And the second question is, let's say if I have certain assets I want to share and they're in the block and they're part of a blockchain, and a couple years after, I became a billionaire and I have more assets I can share. How do you approach that?
Well, again, no, it's okay. So again, the important thing is MongoDB is not really aware that this is a blockchain, right? So it's just documents in MongoDB. So I can perform any search queries, any analytics. I can divide this data. I can shard it. I can put it into zone sharding. So I can actually use MongoDB to store my historical data somewhere and my new block somewhere else, right? So I can optimize the way I access data. So as long as this data is inside MongoDB, I can have different applications query it. So as you said, if I became a billionaire and now I want to share some other stuff, so there will be another transaction created with a new timestamp, right? With a newer timestamp. And that means that this is the actual data, right?
Yeah.
Yeah.
Okay.
So databases, because this is a distributed database that already scales, right? We don't have to sort of discuss that. Scalability piece you sort of get for free, right? Because you're not storing your data in a file system. You're not storing it kind of natively where it's hard to get at or any key values stored.
Yeah.
No, I understand all that. I was just interested in your design. How did you guys, like, I'm sure you guys, thought about certain key aspects of your, like, it has to be this, and that, right?
Okay.
So I was just interested in that particular design. So if this happens, how would you approach that?
Well, yeah, I'm using an Atlas cluster, right? So currently it's a replica set. I can easily do it a sharded cluster and distribute it across the globe for access. And we didn't talk about it, but since this is already a collection, I can take a collection and shard it whenever I want, right? And I can decide what is the window of my sharding. Does that somehow make sense? So this is a more simplified version of design, and this is because we had limited time to build this, but we actually want to build it. I think I didn't address the graph lookup traverse one, and I'm going to address it quickly. So as long as you have the right indexes in place, up until a certain point, that should be pretty good. Again, depends on your block size because you can basically use excessive memory. In those terms, we can persist those blocks, and then we can, actually traverse, traverse a persistent collection. The ways to persist it, is either write the approved blocks and not just mark them as approved by majority. But as long as you have, as long as you have the right indexes and you can shard the collection, you can basically grow it to a large amount, and it'd still be pretty efficient. Yeah.
Question. The secure point of view, from your demo, you're sharing financial information.
Yeah.
So my understanding is once you put something on the blockchain, it's accessible to everyone. It's part of the information. So like in your case,
Inside the private network.
This is a private, this is not, this is not the
Okay.
blockchain. It's
Yeah.
the blockchain within
Yeah.
a set of.
So I can limit the amount of domains. Yeah, but that's fine. That's a good question.
To that point, a user in this demo app could not revoke shared information because it's already on the blockchain. It's immutable. Is that true?
Yeah, and that aspect, like this one.
Once the user of the app grants permission,
Not,
Yeah, exactly. It's state.
not people, but the financial institutions. Yeah, but yeah. Well, we can discuss it later. Like the vulnerability. Yeah, maybe it's not perfect. Like I agree.
I understand it's
Yeah.